Alright, I'm Isaiah, and it's my first time doing a video, so I hope it comes out well.
I'm Chris Diaz, and this is my second time doing a video, so hope you like it.
My name is Victor. This is my 5th time doing a video, so hope you like it.
Oh, this is Unit 5. Okay, so you start off with the problem in rational exponent form, and then you want to put it into radical form, which is moving the denominator inside of the parentheses and the numerator outside as an exponent. You try to find what multiplied by itself 6 times equals 64, which is 2, and then you want to cube it, which equals 8. And then for the second example, we did negative 32, and then to always get a negative, you want to use an odd number. If you use an even number, you're going to get a positive. So then the answer is negative 2, and negative 2 cubed is negative 8.
So we're on properties of rational exponents and radicals. So the first example is product of powers, and you simply add the exponents. 6 plus 4 plus 3 equals x to the 13th power. And then you get, the next example is you combine like terms, and it's 4 times 7 equals 28. And then you add 3 plus 8, and you get 28x to the 11th power.
You got the power of power. So in this column right here, we got x m to the power of L, which is going to come out to equal xm times L. Second example, we got x6 to the power of 2, which is going to come out with x6 times 2 equals x12. Then for the third one, we got 4 cubed to the power of 2, and 4 cubed is 64. And then to the power of 2 equals 4,996.
Alright, so now we're on the zero exponent part. Basically everything to the 0 power equals 1. So x to the 0 power equals 1. Even a number like 6,987,659 to the 0 power is still 1.
So here the quotient of powers. So whenever you divide powers, basically like subtracting them. So right here you have k to x to the power j, and then x to the power k, which is going to come out to be x j minus k. And right here, 6 to the power of 9, and then 6 to the power of 2, and then you're supposed to divide them, but you subtract them, so it's going to be 6, 9 minus 2, which equals 7, and then you get the answer. And then for this one, x to the power of 4 over x to the power of 6, which is x 4 minus 6, and then equals x negative 2, but you can't have a negative 2, so you just have to put that all over 1.
For the power of the quotient, you're going to just basically multiply everything by the exponent. So if you multiply this first one, it's just gonna equal j to the power of x over k to the power of x. For the second one, 4 over 5 is just gonna equal 4 squared over 5 squared, which equals 16 over 25. And for the third example, you're just gonna multiply the exponent by every single thing inside the parentheses. 3 cubed equals 27. 2 times 3 equals 6, x to the 6th power. 3 times the 3 on y, which equals y to the 9th power. 4 times 3 is going to equal z to the 12th power. 2 cubed equals 8, which equals 27. X to the 6th power, y to the 9th power, z to the 12th over 8. So now we're on power of a product. Basically, you just multiply the exponent by each variable. So xy to the 4th power is just x to the 4th power and y to the 4th power. For the second equation, x to the 3rd power and y would equal x, and then 3 times 3, which equals x to the 9th power, and y times 3 is y to the 3rd. For the third equation, you're going to do square everything inside the equation, but you always multiply the exponents. So 4 squared is 16. X cubed times 2 is going to equal x to the 6th power and y squared.
So we're on negative exponents. So you have 3 to the negative first power, and you can't have a negative, so you put it all over 1 and you switch the problem. So it's 1 over 3 to the first power, and you get the answer 1 over 3. And the next problem is 4 to the negative second power, and you can't have a negative exponent again, so you put it all over 1, and then you get 1 over 4 squared, and that equals 1/6. over 16.
So now we're on solving radical equations. The hang time problem. If a skateboarder is in the air for 3 seconds, what was his height? If you double the time to 6 seconds, what is the second? The equation for this one is t equals 0.5 square root h. Then you put the seconds equal to the equation. You want to divide by 0.5 on each side, but you want to move that decimal over to keep this a whole number, to keep it simple. This cancels out, and you're left with the square root h, where you want to get rid of that square root by squaring it, and then you're going to square the 6 too, so you get h equals 36 feet. And for the second one, where you need to double the equation, you're going to divide by 0.5 again, canceling that out, but you want to keep this a whole number. 12 squared equals the square root of h, and then you want to square it, and you get h equals 144 feet. I feel like we all put a good amount of effort each towards the video.
Feel like it was pretty easy, except explaining it in math terms. I think was one of the most complicated parts.
Yeah.
I think there shouldn't be any improvements to our video because we tried really hard on it and took a long time to do it.
Yeah. And
So,
So like for the love languages part, I feel that we all need to like figure out each person's love language, because as you said in class, like you like made a mistake for the past 20 years or so with trying to love everyone the way you like to be loved, but you need to find out like everyone does have different like needs and stuff, like with the love languages, like each one can contain a different type.
Oh yeah, shout out to the Chargers.